Hello Earth Science students, today we're going to be doing a demonstration of air pressure using a empty soda can. So when we have an empty pop can like this, or I guess LaCroix can in my case, it's not truly empty because inside of it, it's still full of air. Air, as you know, exerts pressure in all directions. So the air outside of the can is exerting pressure on the outside of the can, and the air inside of the can is exerting pressure on the walls of the inside of the can, and this pressure exertion is equal on the inside and the outside of the can, so that the can is just stable. It's just sitting here. So what I'm going to do is I'm going to put just a little bit of water inside the empty can, and now I'm going to place it on a heat source for a couple of minutes. While I am heating this can, the water inside is going to begin to boil, and as water boils, it turns into steam, which is just a very hot form of water vapor. And as the water vapor is produced by the boiling, it will eventually push all of the air outside of the can. So now the pressure being exerted on the outside of the can will be from regular air outside, but the pressure being exerted inside of the can is going to be from water vapor pressure instead of air pressure. But again, these two pressures are still going to be equal, so the can is going to remain stable. It's just going to sit here. So now we have to give this a minute until the water starts to boil. So what I'm waiting for is to hear some little popping noises of water boiling inside of the can, and also I should be able to see steam coming out of the open mouth of the can eventually. I'm starting to see just a little bit of steam coming out of the opening of the can, so that means we're getting close. This is a good exercise in patience. I'm starting to hear a little bit of noises coming from inside of the can, indicating that the water is starting to boil. Hold this closer, maybe it'll pick up the sound of the boiling water. We'll watch and see if we can see water vapor rising out of the can. I can definitely hear the water boiling inside now. Just gonna wait a second to make sure that the can is completely filled with water vapor instead of air. And the way that we'll know again is by seeing water vapor coming out of the open mouth of the can. Waiting to see nice tendrils of water vapor coming out of the mouth of the can, because we really need to make sure that the can is filled with water vapor instead of air. So you gotta give it a minute to let the water vapor push all of the air out of the can. It's really hard to see on the camera, but there is some water vapor coming out. Maybe if I hold it over, you can see a little bit of, you can see the water boiling inside of the can. There's a little bit of steam coming out of the hole of the can. So I think at this point we're ready to do the demonstration. So in addition to my can on a heat source, I also have a dish of ice water, very cold ice water, and some heat resistant Gravitong things. So what I'm going to do is I'm going to carefully grab my can with the tongs and quickly take it off of the heat source and invert it so that the open mouth of the can is under the surface of the ice water into the ice water. Ready? Here we go. Okay, so you can see that as the can was inverted into the ice water, it was crushed. So the reason for that is because the water vapor inside of the can when it was on the heat source was very hot water vapor, and as it was put into the ice water, it went through condensation very, very rapidly. And then there was now, since the mouth of the can was underneath the water, there was no way for air to get inside the can to equalize the air pressure, and so the air pressure outside of the can was more than the air pressure inside of the can. The air pressure inside of the can dropped significantly as the water vapor condensed. So again, the pressure inside the can was less than the pressure outside the can, so the can was crushed, or the technical term that we use for this is imploded. Implosion is the opposite of explosion. When pressure is greater on the outside of something than inside, then that thing will crush down or implode. When pressure is greater inside something than outside, then that thing will explode outwards.